and asking where can I assume the reference to locate the centroid. As you watch my screen, I prefer to assume the reference at the lower edge and the vertical reference at the farthest edge, because sometimes this length not equal to this one. So I'm gonna assume the horizontal reference at the lowest edge of the cross section and the vertical reference at the farthest left edge. Okay, so your cross section here looks like this shape, but I'm drawing it in an isometric shape, but the actual cross section is this one. And here the cross section looks like channel, this shape. And the cross section here looks like double T. This shape. But what I did, I draw it in an isometric shape. You got it? This one is drawn as a cross section, not isometric. If you would like to draw it in an isometric shape, you have to extend these lines like this to be isometric. You know what I mean? And this one also, I will assume the horizontal reference here and the vertical reference there. Any question? Any question before starting our meeting today? Okay, looks good. Last meeting, we started with section properties. And I talked about cross section and what is the meaning of cross section. And I started with area. What is the area of rectangle, right angle, triangle, circle, and where is the centroid of these simple shapes? If you have more complicated cross section, which you call the composite area, that means we have many parts connected together. So I can figure out the centroid by this expression and this expression. We can do this using a table to figure out where is the centroid of the given cross section. We have a new section properties today, which is called moment of inertia. Can be called I, moment of inertia, capital I. We need to figure out the moment of inertia about x-axis, so I can call it Ix. And we need to figure out the moment of inertia about y-axis, so I can call it Iy. What is the meaning of moment of inertia? Moment of inertia to understand what is the meaning behind moment of inertia, I would like to explain this example. If you have a piece of wood and you put it between a table or chair, this side and this side, and you are standing at this location, what is your feeling about the strength of this piece of wood? The same piece of wood and the same person standing on the wood, but the piece of wood looks like this shape. Which one will be stronger than the other one? What is your expectation? What is your expectation? The right side is stronger or the left side is stronger? What do you think? Make sure the same material, the same piece of wood, the same dimension, everything the same, but only this position is horizontal position, this position is a vertical position. That's it. The same person. That means the same weight. What do you think? Which one is stronger? The right one. That makes sense. That makes sense. But what is the philosophy? What is the reason behind this difference? I told you the same material, the same dimension, the same weight, everything the same. The only difference, I flip this piece of wood to be vertical, not in a horizontal position. So what is the reason behind this difference in behavior? Is moment of inertia. The moment of inertia, I, in this case, is greater than the moment of inertia, I, in this case. So it's a measure of an object, the resistance to change to its rotation or deflection or moment. So moment of inertia is an indication of the strength of the member. Can be strong or can be weak. We have the value of moment of inertia for these three basic shapes: rectangle, circle, right angle triangle. Moment of inertia, I for rectangle equal to parallel time perpendicular cube over 12. I'm sorry, what you mean by parallel time perpendicular cube over 12? As I told you, if you have a rectangle with dimension b time h, and I told you for I, we have ix about x-axis, and we have iy about y-axis. If you are talking about ix, if you have ix, so parallel to x, which side of the rectangle is parallel to x? B. Which side is perpendicular to x? H cube over 12. So ix will be b parallel h cube, which is perpendicular cube, divide 12. Parallel to what and perpendicular to what? I'm talking about ix, so parallel to x and perpendicular to x. If you are talking about iy, so which side is parallel to y? Will be h. Which side is perpendicular to y? Will be b. So h b cube divide 12. So if you would like to figure out the value of ix, parallel time perpendicular cube over 12, I can give it an example. I can give you an example. If you have a rectangle with 25-inch length and 12-inch, okay, let's change it, 12, 14-inch width, and we have here the centroid. At this centroid we have x-axis, at this centroid we have y-axis. Can you tell me what is the value of ix? Can you tell me what is the value of iy? Okay, ix will be the parallel to what? Parallel to x. I'm talking about ix. So parallel to x. Which one is parallel to x? 25. Which one perpendicular to x? 14. Cube over 12. So I can figure out the value. If you are talking about IY, moment of inertia about y-axis, okay, parallel to y, which side is parallel to y? 14. Which side perpendicular to y? 25. Cube over 12. So I can figure out the value for IY. Any questions so far? Did you understand what is the value for IX? What is the value for IY for a rectangle? Any question for this point? Okay, looks good. Josie, do you have any question? Okay, looks good. The second one, for a rectangle, I'm sorry, for right angle triangle, I equal to parallel time perpendicular cube over 36. The only difference between a rectangle shape and rectangular shape and triangular shape is 36 and 12. This one is parallel time perpendicular cube over 12. This one is parallel time perpendicular cube over 36. So if you have right angle triangle like this one, the base length is 20 inch. The height is 18 inch. The centroid of this right angle triangle is here. Do you remember that? And we have x-axis and we have y-axis. If I'm asking what is the value of ix and what is the value of iy, it's very easy. Parallel, I'm talking about ix, so parallel to x. Which side or which dimension parallel to x? 20. Perpendicular to x, 18 cube over 36. So I can figure out the value. IY, I'm talking about y, IY, so parallel to y, 18, perpendicular to y, 20, cube over 36. So I can figure out the value of IY. It's very easy. I'm trying to help you to understand and to remember it all the time. So keep this and this one in your mind. Don't try to use BH cube over 12 or HB cube. It can confuse you a little bit. But parallel to your axis, time perpendicular to this axis cube over 12 is more easy. For a circle, no, we don't need parallel or perpendicular because IX equal IY. Both of them equal. Do you know why? Both of them equal. Do you know why? Because for rectangle, we have two positions for this piece of wood. So we have one is stronger than the other one. So one of them will be IX, the other one will be IY, and the strongest position is greater than the weakest position. But if this piece of wood looks like a circle, like this, looks like a cylinder with a circular cross section. Do you think if you have a piece of wood looks like this, do you think we have a position stronger than another position? Guys, what do you think? If your member has a cross section looks like a circle, do you think we have a position is stronger than another position in this case? What is your answer? I think they are equal in all positions. That makes sense. So if you have a piece of wood looks like this one, there is no position stronger than another one. That means I, X equal I, Y equal any I for any axis. If you have another axis, all of them are equal. This is the reason why if you have a circle, if you have a cross section as a circle, Ix equal Iy equal by R to power 4 divide 4, or equal to by diameter to power 4 divide 64. This one is correct and this one is correct. The only difference here, I'm using radius, but here I'm using diameter. So this slide is very important. This slide is very important. If you have rectangular shape, moment of inertia about X or about Y, parallel time perpendicular cube over 12. If you have right angle triangle and we need to figure out Ix or Iy, so parallel time perpendicular cube over 36. If you have a circle and you are looking for Ix and Iy, both of them are equal. Ix equal Iy. There is no difference. Equal, if you would like to use radius, by time radius to power 4 divide 4. If you would like to use diameter, by time diameter to power 4 divide 64. Any questions so far? Any questions so far? So, for example, if you have a circle and this circle has a radius equal 5 inch, Ix equal Iy for this circle equal by time radius to power 4 divide 4, or equal by time diameter, which is 10 to power 4 divide 64. Believe me, this number will be the same like this number. Any questions so far? Looks good. Looks easy. So, but we have a condition to use this one, parallel time perpendicular cube over 12, or to use this one, parallel time perpendicular cube over 36, or using this one. We have one condition, must be valid. What is the condition? This x-axis and this y-axis must passing through the centroid of this rectangle. This x-axis and this y-axis must passing through the centroid of this right angle triangle. This x-axis and y-axis for this circle must passing through the centroid of this circle. This is happening all the time? No, unfortunately, no. Sometimes we have a rectangle and here is the x-axis. Sure? Yeah, I'm looking for Ix. Do you think the x-axis is passing through the centroid of this rectangle? No. So your question is, I believe you would like to ask this question. Your question is, which situation we can find this one? I believe all situations. If you go back to example number 1, do you remember it? Yeah, we remember this one. After your calculation, you discovered that the centroid for this cross section at this point. At this point, I can put x-axis and y-axis for the whole cross section. That's fine? That's fine. What do you think about this rectangle shape? Do you remember part number 1? This rectangle shape. This rectangle has a centroid at this location. Do you think x-axis for the whole cross section passing through the centroid for this rectangle? No. So we can find this case all the time. We have a rectangle, or we have right angle triangle with a centroid, but the x-axis is far away from the centroid, or y-axis is far away from the centroid, like this or like this. You told me I can use these expressions only if x-axis and y-axis passing through the centroid of this shape. What will happen if the x-axis not passing through? Actually, ix will be two parts. The first part, I'm gonna assume my x-axis is here. Just assumption. Just assumption. So your ix will be b times h cube divide 12 parallel times perpendicular cube over 12. But this is assumption. Do you think this one is the correct x-axis? No, the correct x-axis is here. So I'm gonna move it by this distance. So I need to add another part equal area for this rectangle times d square. If you add this term plus this term, that means you can get ix for this rectangle about this axis. If I'm looking for iy, okay, I will assume y-axis is here. Just assume, just assumption. So we have h times b cube over 12. Parallel times perpendicular cube over 12. This is the first term. The second term, no, the y-axis, the correct y-axis is moved in this direction by distance. We can assume it x. So I need to add area for this rectangle times x square. So the moment of inertia of an area with respect to any given axis is equal to the moment of inertia with respect to the centroidal axis plus the product of the area and the square distance. Area times square distance. Area times square distance if you have transition. Transition means we have assumed x-axis, but the actual x-axis is translated or moved a little bit with distance d, so we need to add a new term, this term called term of transition. Any question for this point? I will do example, and through the example you can understand it more and more. We have a cross section given, and we need to locate the centroid. So we need to go back to the previous meeting and figure out how can I locate the centroid. Do you remember that? First step, I will divide this cross section to 3 parts. part number 1 with this centroid. Part number 2 with this centroid. Part number 3 with this centroid. Second step, I would like to assume I have a reference here at this edge, and I will have another reference here at this edge. Reference number 1 and reference number 2. The third step, I'm gonna set up this table. How many parts did you divide this cross section? 3 parts. Number 1, number 2, number 3. What is the area of part number 1? Can you do it? What is the area of part number 1? Part number 1 looks like rectangle 30 times 10, so 300. Part number 2 is another rectangle 100 times, not given. The thickness is 10 inch. So 100 times 10 will be 1000. Part number 3 is 30 times 10 will be 300. X bar. What is the horizontal distance? Because X is a horizontal. What is the horizontal distance between centroid of part number 1 and your assumed reference? 15. What is the horizontal distance between the centroid of part number 2 and your reference? 15. What is the horizontal distance between the centroid of part number 2 and your vertical reference? 15. Can you multiply area times X? This column times this column. So 300 times 15, 4,500. 15,000. 4,500. Can you get summation for this column, which called summation area? Can you get summation for this column, which you call summation area times X bar? Yeah, I can do. This one will be 24,000. This one will be 1,600. One more time. I'm gonna add another term here called Y bar. Y means vertical distance. So what is the vertical distance between your assumed reference and this centroid? 5. What is the vertical distance between this centroid and your assumed reference? I believe it will be 60. What is the vertical distance between this centroid and the assumed reference, the horizontal reference? I think it will be 110, 115. Can you multiply area, which is this column, times this column, times Y bar? Yeah. 5 times 300 will be 1,500. 60 times will be 60,000. 115 times 300, it will be 34,500. Go ahead and get the summation here. $96,000. This summation can be called the summation area Y bar. Guys, do you remember how can I figure out the X bar and Y bar for the centroid? This term was summation area. X bar divide summation area. What is the value of summation area X bar? 24,000. What is the value of summation area? 1,600. This value will be 15. Y bar, if you go back, summation area, Y bar divide summation area. Summation area Y bar 96,000. Summation area 1,600. This value will be 60. So, guys, I'm gonna delete everything here. I don't need this reference anymore. And just to remind you, we have a reference here. We have another reference here. From this origin for the assumed references. From this point, I will walk horizontally, distance equal 15. And then walk up, distance equal 60. To reach to this point, which is the centroid for this whole cross section. At this centroid, I can put my x-axis and my y-axis for this cross section. So just to remind you, this vertical distance, I moved up by 60. This horizontal distance that I moved horizontally was 15. Inch. We covered this last time, but do you have any question for locating centroid? Guys, do you have any question for locating centroid? Okay. But the second part in this problem, we need to calculate moment of inertia about x and y axis. This x-axis and this y-axis who are passing through this centroid. I will delete this table to set up another table. So this table for centroid. In your exam, don't delete the table. I'm deleting it because I don't have enough space. Because one of you will say, hey, Dr. Ayman, after he is done, he deleted the table. No, I'm deleting right now because I don't have enough space. So after you are done with the first part of the problem by locating the centroid and setting up this table, we will set up a new table. Why? To calculate moment of inertia. A new table. This table, number, how many parts? We have 3. Part number 1, part number 2, part number 3. What is the area of the first part? Do you remember that? 300. Area of part number 2, 1000. Area of part number 3, 300. What is the value of Ix? Part number 1. Here is the centroid of this part only. I'm talking about the part only. This part only. If you assumed here is your x-axis So what is the Ix value? It will be 30 times 10 cube over 12. Do you agree? If you have any question, let me know. This rectangle is 30 times 10. And I assumed my x-axis at this centroid for this part only. So your moment of inertia will be parallel time perpendicular cube divide 12. It will be 2,500. Part number 2. This part of part number 2, which is a vertical rectangle, has a centroid here. I'm gonna assume my x at this location, so it will be parallel time perpendicular cube over 12 time 10 times 100 cube over 12. This number will be a huge number, 83333.33. Part number 3, we have a part here, rectangle, with this centroid. I'm gonna assume my x is here. So 30 times 10 cube over 12, it will be 2,500. I have a question. In this step, you assumed your x-axis for this part is here, and the x-axis for this part is here, and the x-axis for this part is here. You assumed, but your assumption is not correct because we have only one x-axis for the whole cross section. So we need to figure out the distance t. What is the distance between the assumed x-axis for part number 1 and the correct x-axis? Can you figure it out? What is the vertical distance between the assumed x-axis for part number 1 and the correct x-axis for the whole cross section? I believe this distance will be 55. What is the distance between the assumed x-axis for part number 2 and the correct x-axis? I believe we don't have distance. They are coinciding. What is the distance between the assumed x-axis for part number 3 and the correct x-axis for the whole cross section? What is the vertical distance here? I believe it will be 55. Can you get area times d square? This column times this column square. So 300 times 55 square, it will be this number. This one will be 0. This one will be the same number. Can you get the summation for Ix? Add this number plus this one plus this one. So we have 2,500 plus 2,500 plus 83333.33. This number will be 83833.33. Can you get the summation for area d square? Summation for this column 90,752.0. This one will be 18,150.000. That means Ix for the whole cross section will be this number plus this number. The final answer will be 2,653,333 inch to power 4. Guys, if you go back here, do you remember I told you if the x-axis passing through the centroid of the shape of or the part is far away from the actual or the correct x-axis, so we need to add this part plus this part. This is what I did. I added this part plus this part, ix plus area d square. But because we have many parts for this cross section, so I added these numbers first, and then add them together to get the final ix. Any question? Hey, don't forget, I only calculated ix. I still need to figure out the value of iy. I will set up another table. Don't go away. I'm still working. To figure out the value of iy, so this table for ix. Yeah, sure. You in your exam, you have to set up 3 tables. The third table to figure out the value for iy. The same number of parts. We have 1, 2, 3. What is the area of each part? Do you remember that? 300, 1000, 300. What is the value of iy? Okay. I will assume what? We have here y-axis at this centroid for this part. So we have 10 parallel times 30 cube over 12. What is the value? Second part, we have here the y-axis. I assume here is the y-axis at this centroid for this part, part number 2. Parallel to y will be 100. So 100 times 10 cube over 12. The third part, we have here, I will assume here, y-axis. So parallel to y will be 10 times 30 cube over 12. What are these numbers? So 10 times 30 cube over 12, it will be 22,500. This one will be 22,500. But this one will be 8,333.33. What is the distance d? Guys, make sure you understand this point. I will clean up to make it clear. At the beginning, you locate the centroid for the whole section here and put x-axis and you put y-axis. At this moment, we have a part number 1 and you assumed you have here y-axis for this part only. Do you think you have a distance between y-axis for this part and y-axis for the whole cross section? Do you have any horizontal distance? No, we don't have, because both of them are coincides at the same location. We don't have distance. Second one, here is the y-axis for the second one, second part, At the same location, we have y-axis for the whole cross-section, coincides, so we don't have distance. For part number 3, here at this centroid, I assumed y-axis at the same location for the whole cross-section y-axis, so we don't have distance. You are lucky. Go ahead and multiply area times d square. Area times d square 0. Area times d square 0. Area times d square 0. Go ahead and get summation here. Go ahead and get summation here. We have 0 here. We have $5,003. So the final value for IY will be this number plus this number. If you have one, put it. So the final value will be this number inch to 4. I would like to make it clear for you. Please pay attention one more time. Please pay attention one more time because this one is confused a little bit. If you are talking about IX, if you are talking about IY, here is the x-axis at this centroid for the whole cross section. Here is the y-axis at this centroid for the whole cross section. If you are calculating IX, okay, for part number 1, I assumed x-axis here. So we have distance. I assumed x-axis here for part number 2. We don't have distance. Coincides. For part number 3, I assumed the x-axis here, so we have distance. So if you go back to table number 1, we have distance, we don't have distance, we have distance. If you calculate IY, okay, at this part, I assumed y-axis for this part. Y-axis for this part and y-axis for the whole cross section, all of them at the same line, so we don't have distance. Second part, I assume the y-axis for the second part here. Y-axis for the second part and y-axis for the whole cross section at the same line, so we don't have distance. Y-axis for the third part and y-axis for the whole cross section at the same line, so we don't have distance. So we don't have distance, we don't have distance, we don't have distance. So by the end, you should set up 3 tables. The first one to locate the centroid, the second one to calculate IX, the third one to calculate IY.